Timeless concepts from Physics Helpline. In this video tutorial, we will discuss 4 multiple choice questions taken from the NEET exam of 2018. The questions are as follows. Question 1. We are given a sample of 0.1 gram of water. Its temperature is 100 degrees C. It is at normal pressure of 1.013 into 10 to the power 5 newtons per meter square. This sample requires 54 calories of heat to convert into steam at 100 degrees C. If the volume of steam produced is 167.1 cc, then we are required to find the change in internal energy of the sample. The options are given in the question. We are required to find the correct option. Now for the answer. First, let us calculate the work done by the system. Delta W is equal to P into delta V, pressure into change in volume. Pressure P into change in volume is final volume is volume of steam minus volume of water. So P pressure is 1.013 into 10 to the power 5. Volume of steam is 167.1 cm cubed. We multiply by 10 to the power minus 6 to give it in SI units, minus volume of water. Now volume of 0.1 gram of water is equal to 0.1 cc. Therefore, delta V is equal to 167.1 minus 0.1 into 10 to the power minus 6. Since everything is in SI units, we get delta W in joules. Simplifying, we get this as equal to 1.013, that is what we have kept here, and 167.1 minus 0.1 gives us 167 into 10 to the power 5 and 10 to the power minus 6 gives us 10 to the power minus 1. Simplifying, we get delta W is equal to 16.917 joules. Now, for the heat absorbed by the system, it is given in the question that delta Q is equal to 54 calories. But we want to convert it into joules, which is equal to 54 into 4.18 joules. Simplifying, we get delta Q is equal to 225.72 joules. Now, the first law of thermodynamics gives delta Q is equal to delta U plus delta W. Therefore, delta U is equal to delta Q minus delta W. We'll put the values of delta Q and delta W from this, which gives delta U is equal to 208.8 joules, which is the answer to question 1. Therefore, the correct option is B. Now for question 2. This is about a small sphere of radius r which falls from rest in a viscous liquid. As a result, heat is produced due to the viscous force. We are required to find the rate of production of heat when the sphere attains its terminal velocity. This rate of production of heat will be proportional to some power of radius r of the sphere. The options are given in the question. We are required to find the correct option. Now for the answer. The rate of heat produced dq by dt will be equal to force multiplied by velocity. So here the force is viscous force Fv multiplied by the velocity is nothing but the terminal velocity of the sphere. So the viscous force is given by Fv is equal to 6 pi eta Rv. But at terminal velocity, Fv will be equal to 6 pi eta R into Vt. Therefore, dq by dt will be equal to 6 pi eta R Vt into Vt gives us Vt square. Therefore, we get dq by dt is directly proportional to R into Vt whole square, because other things are constants. Now, terminal velocity Vt is equal to 2r square divided by 9 eta into rho minus sigma into g, where rho is the density of the ball and sphere and sigma is the density of the viscous fluid. From this we get everything else is constant, therefore we get Vt is proportional to r square. Therefore, equation 2 gives dq by dt is directly proportional to r into r square whole square. Therefore, we get dq by dt is directly proportional to r to the power 5, which is the answer to question 2. Therefore, the correct option is C. Now, for question 3, it is about a solid sphere in rolling motion. In rolling motion, a body possesses both translational kinetic energy kT as well as rotational kinetic energy kr simultaneously. We are required to find the ratio kT is to kT plus kr. kT is the translational kinetic energy and kT plus kr is the total kinetic energy for the sphere. The options are given in the question. We are required to find the correct option. Now for the answer. For a sphere, the moment of inertia I is equal to 2 by 5 mr square. It is in pure rolling motion. Let the angular velocity is equal to omega. Then linear velocity will be given by v is equal to r into omega. Therefore, rotational kinetic energy kr is equal to half I omega square. Therefore, half into I is equal to 2 by 5 mr square into omega square, which is equal to 2 and 2 gets cancelled. We get kr is equal to 1 by 5 mr square omega square. But we know that r omega is equal to v, therefore r square omega square is equal to v square. This gives us kr is equal to 1 by 5 mv square. Again, translational kinetic energy kT is equal to half mv square, because m is the mass of the ball and sphere and v is its velocity. From this we get kT plus kr is equal to half mv square plus 1 by 5 mv square. Adding we get kT plus kr is equal to 7 by 10 mv square. Now for the required ratio, kT divided by kT plus kr is equal to half mv square divided by 7 by 10 mv square. So mv square and mv square gets cancelled. 1 by 2 is 0.5 and 7 by 10 is equal to 0.7, which is equal to 5 by 7. Therefore, we write kT is to kT plus kr is equal to 5 is to 7, which is the answer to question 3. Therefore, the correct option is B. Now for question 4. We are given a tuning fork whose frequency is given as 320 Hz. It is used to produce resonance in a glass tube. The length of the air column in the tube can be adjusted by a variable piston. The room temperature is 27 degrees C. We are given that the two successive resonances produced at 20 centimeters and 73 centimeters of air column. Then we are required to find the velocity of sound in air at 27 degrees C. The options are given in the question. We are required to find the correct option. Let us first understand the related concepts. Let us understand the resonance tube. The first resonance is shown in the first figure, in this figure. When the piston is moved from top downwards and we put at a vibrating tuning fork of frequency f at its mouth, we observe that when the length of air column vibrating is equal to L1, we get the first resonance. Therefore, we write first resonance length is equal to L1. Similarly, for the second resonance, the length will be L2. When the piston is in this position, L2 at a distance L2 from the open end, then we get the second resonance. Therefore, we write second resonance length is equal to L2. So first resonance, you can see that when the open end has got an antinode and the closed end has got a node. Here, the open end, antinode and the closed end node, and there is an additional node in between. So this is the second resonance length, contains 1.5 loops, and this has got only half loop. Therefore, the difference L2 minus L1 will be equal to the length of one loop, which is equal to half a wavelength. Therefore, we write L2 minus L1 is equal to lambda by 2. Therefore, lambda is equal to 2 into L2 minus L1. Now, frequency of the vibrating air column is the same as frequency of the tuning fork. Therefore, we write V is equal to F into lambda. Therefore, putting the value, putting F, V is equal to F lambda, which is equal to 2F into L2 minus L1. Now, for the answer, it is given in the question that L1 is equal to 20 centimeters, which is equal to 0.2 meters, and L2 is equal to 73 centimeters, which is equal to 0.73 meters, and frequency of the tuning fork F is equal to 320 Hz. Therefore, we will use the equation V is equal to 2F into L2 minus L1. Putting the values, we get 2 into 320 into 0.73 minus 0.2. So 320 into 2 gives us 640, multiplied by 0.73 minus 0.2 gives us 0.53. Simplifying, we get V is equal to 339.2 meters per second, which is the answer to question 4. Therefore, the correct option is B. This completes the answer to all the questions in this video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.